All right, so this is going to be another example problem involving definite integrals, only this time it's going to involve a little bit of use substitution. As you can see right here, we have this buried function right here, and its derivative leads us to something that's related to this over here. So it's really good to see that pattern ahead of time to know that you need to do use substitution for this. Forgot the dx at the end of this problem. Okay, first thing I'm going to do is figure out what my u is. 99 times out of 100, it's going to be whatever the most buried function is. In this case, it's that x squared plus 2x. Is your u. We need the dx, so the only way to get a dx out of this is to do the derivative, and you get 2x plus 2. Okay, but we want to solve for this dx right here, so I'm going to multiply both sides by dx. Okay, dx is going to cancel. You have du equal to 2x plus 2 times dx here. Now we need this x plus 1, and you can see if you just divide this by 2 here, you end up with that x plus 1. So you're going to end up with du over 2 is equal to quantity x plus 1 dx, which is everything we need to be substituted for at that top expression. Okay, here's where it gets a little tricky. You have this 0 to 1 here, but that's with respect to x. So that's x is equal to 1, x is equal to 0. We want to turn this entire definite integral into terms of u. So what we can do is change that 1 and that 0 to be in terms of u. So now this definite integral, the 0, you can actually just plug it into this u equation. So it's 0 squared plus 2 times 0. That's equal to 0. And then if we do the same thing with the 1 now, you're going to get 1 squared plus 2 times 1, which is 1 plus 2 is 3. So now you can put a 3 up there. Now you can answer this definite integral without having to go back in terms of x. You can just keep it in terms of u and solve it. So it's kind of a little shortcut, and I'll show you how the rest of it goes, but it definitely saves you a little bit of time. Okay, so here we're going to do the x plus 1 dx. That's going to be du over 2, so I'm going to write that over here, du over 2, and then it's e to that x squared plus 2x, which is our u in this case. Okay, you do the antiderivative of e to the u. It's just going to be e to the u. I'm going to pull the 1/2 in front, e to the u, and we're integrating from 0 to 3. Now if you notice, I can just keep it in terms of u. I don't have to plug this u back in, this x part right here, in for the u. Don't even need to worry about it. I can just solve this integral. So you're going to end up with 1/2 times the quantity e cubed minus e to the 0, which is just 1, because anything with 0 power is 1, except 0. And you end up with an answer that looks something like this right here. All right, so that's basically an example problem using use substitution with definite integrals. If you have any questions about anything in this video, let me know.